So now that we've talked about ordering, let's go back and revisit partitioning, and we'll take a look at how parallel streams partition a data source up into chunks. So this is really what the spliterators are doing. So before, we've talked about what a spliterator is. Remember, that's a splittable iterator that's used to do two things, traverse and partition. We've talked earlier in one of our lessons from a couple weeks ago about how traversal occurs. So you can use a spliterator in order to essentially iterate through every element in the spliterator, which of course is connected to a collection, as we show here. And now we're going to talk about how you can use a parallel spliterator in a parallel stream to partition the elements in a source. And this is a lot more interesting in some ways than the iteration part, or the part that just goes ahead and traverses. So the magic here centers around a method called try-split. And the try-split method is called by the Java Streams framework for parallel streams, not for sequential streams, for parallel streams. It's typically not called by your app. I mean, you could call it if you wanted to, but it would be wasteful because it's not really intended to be used in this way. So try-split is the hook method defined on spliterator that you typically implement. And its purpose, if you do it well, is to try to split things in half. So as you can see here, if you're not a minimum size, we'll talk about the minimum size in a second, you want to split the input into two hopefully evenly sized chunks, and then you update this object to hold the right-hand side of the split, and then you return a new spliterator for the left-hand side of the split. Typically, you don't need to have any locking or synchronization. You don't need to do any joining. All that kind of stuff is handled for you by the framework. The framework is very careful how it does the splitting, so it only ever does splitting in. The splitting that takes place is never going to compromise this state as long as you implement things to split in a way that's mutually exclusive. The try-split method is called back recursively to try to split the subchunks up into sub-subchunks, into sub-sub-subchunks, and so on, until all the chunks are less than or equal to some user-defined minimum size. For things like array lists, the user-defined minimum size is like 1, right? You split until you get one element. As we'll see later when we talk about defining parallel spliterators for the search stream gang example, we're going to define how big or small we want those chunks to be ourselves, and they aren't going to be sized to size 1 for reasons that will become clear when we talk about it. When you get to the minimum size, you return null. That's a flag to indicate to the framework, I'm done splitting. And once you are done splitting, then what's left over is then processed sequentially by one of the worker threads in the fork join pool, in the common fork join pool. So once you've got to the point where you return null, then at that point there's a sequential processing, and that sequential processing is going to use try advance to sequentially go through the results that came back. Let's take a look at a couple of cool examples. These are all from the Java source code. This should look actually very familiar to you at this point because you've implemented something like this. These are the try-split and try-advance methods that are defined on array lists. So if you go and take a look at the source code for array list, you'll see this. The try-split method, as you can see, tries to evenly split the array each time until there's nothing left to split, and that should look very familiar. So we basically take the low and the high. High is defined by something called getFence. And then we take the mid, which is low plus high divided by 2 or right shifted by 1. And if low is greater than or equal to mid, then we're done because we don't have anything left to split. Otherwise, we go ahead and make a new array list spliterator, and we are going to set our index to mid, and we're going to go ahead and create a new spliterator that'll go from low to index, to mid. Okay, so that's how you split things. Here's what try advance does. This again should look very familiar. So if there's actually anything to advance, if we're not at the end of the range, then we go ahead and accept the next item from the element, and that goes into the action, and that gets returned back to the framework. So that's what array list looks like. And the nice thing about array list, as I showed you here is it splits things evenly, and as you can see, it splits it very efficiently because it's just sort of a computation to split things right in the middle. Let's take a look at a data structure, that Java collection, in this case linked list, that doesn't split evenly or efficiently. So here's linked list. As you can see, it's not going to split evenly or efficiently. What it does is it takes the list and it splits it up into batches. So rather than trying to figure out where half the list is, because if you think about a linked list, what's the tricky part about figuring out a linked list? You got to go to the middle. So you'd have to sit there and iterate through a large amount of this stuff trying to find where the middle is. And if you had a big list, you could have things that would be take a long time to find the middle. So instead, what we're going to do is we're going to split things up into batches, where batches some predefined size, like 100 or 10 or something. And so it's not going to split things in half, and it's also not going to split things efficiently, because it's going to have to keep doing this over and over again until it gets it all broken up. Try advance, as you can also see, is a little bit more complicated. So this is just the logic required to figure out how to accept the next element or consume the next element in the linked list. And as you can see, because it's a linked list, you've got to do things like deal with the next pointer, and you have to do other stuff. So it's just a little bit more complicated. We'll talk later when we get to the part of the course where we discuss when to use a parallel stream and when not to use a parallel stream. And I'll show you some performance results from benchmarking using parallel streams with array lists versus using parallel streams with linked lists. And you'll see very quickly when you do that benchmarking that the performance for array list is really fast because it splits evenly and splits efficiently, and the performance for linked list is really slow because it splits unevenly and it takes a while to do the processing. We will talk in much more detail shortly about how to implement parallel spliterators. So we'll talk about the try-split method when we talk about the search with parallel spliterator example, which is really cool, but we'll get to that early next week.